Well, my name is Jeff. My name's Ben.
I'm Andrew.
And I'm Eric.
And we're back. The premise of our project is wind energy. Wind turbines are a wonderful alternative to fossil fuels because they don't produce an output of harmful pollutants.
We're here to find out how the angles of a wind turbine's blades affect the output of electrical energy.
Based on our research, we have formed the hypothesis that the wind turbine will reach its highest efficiency when the blades are angled at 22.5 degrees.
So here's the scheme of things. Us boys working with wind energy and propellers. And not just any propellers. We got wind turbines. What we're working to see is how the angle of these blades affects how much power we produce. Good day, mate. My name's Rick Wallaby, and today we're gonna be explaining the inner workings of this wind turbine. First, we got the general shaft made of Legos. Next, we got the blade, also made of Legos and cardboard. The great thing about these is you can angle them, and that makes it especially easy to customize how you're doing. Finally, we have the gear train, which is hooked up to the motor, which runs to the multimeter, so you can see exactly how much power you're making. Also, I work at the Outback, so if you need a place for dinner, try our seared shrimp, fresh cooked on the barbie. Speaking of Barbie, Santa, can I...
Oh my goodness, you can't see these bloody things. Stupid glasses.
We're filming.
Oh, we're filming. I'm so sorry, come aboard. Let's see. Here's the setup. We have... No, come this way with the camera. Okay. No, not with the stupid stand. You follow me around. Okay, so here, we have this fan. You see this fan? It produces just a little bit more current than Ben Sparks. Now, you see, this spark receptor, propeller, turbine. This turbine right here receives steadfast air energy from the fan. That's redundant. From the fan to the propeller, and it's converted into electrical energy, which is metered here on this multimeter. So, depending on fast, air, wind, comes through here, on this little stream. Okay, you see, one last thing. You see the distance between this turbine, yes, I said it, turbine, and the fan. That expanse is exactly 1.5 yards. Stupid Americans won't convert to metric, but that's a different story. Now, this turbine is weighed down by a brick at the base, and the fan is propped up by a brick from the back, and it is angled to give the right push on the blades.
So here's the procedure. We have a metronome set to 1 click every 10 seconds. So for each click, we will record the voltage displayed on this multimeter. We will be taking 10 readings per angle measure. The angles include 0, 22.5, 45, 67.5, and 90 degrees.
This is our control group. Each of the blades are set to 0 degrees. As you can see, nothing is being picked up on the multimeter. This will be a point of reference for later on. Alright, so this is our first setting. All the blades are set to 22.5 degrees. There's a little bit of fluctuation, but it's usually around 10 volts. Now the blades are set to 45 degrees. Again, a little bit of fluctuation. A little less now, it's usually around 6 volts, more or less.
Now the blades are at our third setting, 67.5 degrees. We're picking up just below 3 volts.
Fourth and final setup. We're at 90 degrees. It's pretty much dead space, moving around randomly. We're getting like 0.01, 0.1. We're basically not getting any power at all.
In conclusion, 22.5 degrees is the best way to go with an average of 13.768 volts.
If we had to do anything different in this project, we probably would have made sure that the neck of the wind turbine was much more stable, because we feel like it could have been a confounding variable in our project.
We're Bay signing out.
Ninja!
That was late. Got it.
Okay, great.
Well, I thought we were doing the dancing again. You
No!
don't do the dancing. We'll cut this out. We can salvage it. We'll cut it out.
Idiot.
My name's
Oh,
Ben.
like for real.
Ben.
Fire. So beautiful. It's flickering down. Fire will cleanse. Yeah.
We're Bay signing out. We're Bay signing out.
That's a bang.
Now we're moving on to our first setting. Each of the blades will be set to 22.5 degrees.
420.